Hello, boys and girls. My name is Latina Gayden. I teach third grade math at Royal Shelling Elementary School. Today, I'm going to present to you Module 1, Lesson 2. If you remember yesterday, we did Module 1, Lesson 1, and we started on the basics of multiplication, and we're going to continue that in Lesson 2. So, let's get started. All right, you guys, let's look at our objective. Remember what I told you an objective is. An objective tells us what we're supposed to learn today. So remember, never leave out of class without knowing your objective, knowing what you were supposed to get out the lesson today, okay? So let's look at what you're supposed to get out of my lesson today. I can relate multiplication to the array model. Okay? You were introduced to arrays, or hopefully you were introduced to arrays at the end of second grade. So today we're going to use arrays to make multiplication sentences, okay? But first, let's do some group counting, and then we're going to review what we learned yesterday. First of all, let's count by twos and threes, okay? So if you don't know how to count by twos and threes, this is a good time to practice. And then you can always practice this on your own. So I'm going to count by twos first, forward and backwards. So really try to concentrate, okay? Let's go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Let's count backwards. 20, 18, 16, 14, 12, 10, 8, 6, 4, 2. Very good, guys. Let's do threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay? That may be new to you because I know when we count by threes, we don't really get past about 15, but in third grade, we go all the way to the tens, which is the 30, okay? So let's count backward by threes, okay? So we're starting with 30. And if you get confused, what I want you to think about is actually going backwards, subtracting 3 every time you say a new number, okay? So when we're skip counting up, we're adding 3. And when we're skip counting backward, we're subtracting 3, okay? So think about subtracting 3 if you get confused, okay? So let's start. 30, 27, 24, 21, 18, 15, 12, 9, 6, 3. Very good, guys. All right, you guys. Let's start with some adding of equal groups. Let's look at what we have, you guys. How many groups are circled? Let's count them. 1, 2, 3. So remember, we talked about the number of groups and the size of groups, all right? So how many groups do we have? That's correct. We have 3 groups. How many in each group? So if I look at each one of these groups, I see 2 red circles in each group. So what do we call that? That's the what of each group. That is the size of the group. Remember, when we're doing multiplication, we're talking about the number of groups times the size of the group equals the total, okay? And remember, when I'm talking about, we already know what the number of groups is because that's clearly how many big circles we have. When we're talking about the size, I always have students confused. When we're talking about the size, we're literally just talking about how many are in each group. And when you look at this picture, you see that there are 2 in each group. So that's the size of the group, okay? Let's write this as an addition sentence. What kind of addition sentence will we have to use to solve this, you guys? We learned that in second grade. That's correct. We will use a repeated addition sentence. When we're talking about repeat, that means we're going to keep adding the same number. So when I add this, I'm just going to take how many groups I have, and then I'll take the size of the group, and that'll be the number I use, okay? So there are 2 in each group, so my repeated addition would look like this. 2, 2, plus 2, plus 2 equals what, you guys? Now we can solve this a couple of ways. We can do some adding or we can do some skip counting. Let's try skip counting, okay? So we would go 2, 4, 6. So 2 plus 2 plus 2 equals 6, okay? So we know that 3 groups of 2 equals 6, all right? Now, we want to write a multiplication sentence for 3 twos equals 6, okay? Remember, we want to do the number of groups times the size of groups. How many groups do we have? That's correct. We have 3 groups times the size of the group, aka how many are in each group? Correct. 3 times 2. Number of groups times the size of the groups equals the total. How many dots do we have in total? That's correct. We have 6. So 3 times 2 equals 6. Let's try it again, guys. Look very closely. How many groups are circled here? Yeah, we have the same number of groups. We have 3 groups, okay? Now we're talking about, let's go to the next slide. How many are there in each group? What are we talking about now? We're talking about the size of each group. Literally, how many are in each group. So what's the size of each group? If I look in each group, I see 5 in each group, okay? Let's write this as an addition sentence. And one thing I want you to remember, the only way to use repeated addition and multiplication is if your groups are equal. You have to have equal groups to relate multiplication to addition. So if I had something where all the groups were the same, I couldn't multiply, right? I would have to stick to addition. So we're trying to do addition for multiplication. So let's look at what we have. So what we want to do is we want to look and see how many are in each group. There are 5 in each group, and that's the number I want to use. How many times am I going to add 5? Well, how many groups do I have? I have 3. So I want to add 5 3 times in a repeated addition sentence. Let's do that. 5 plus 5 plus 5 equals, let's count by 5s. You've been doing this since kindergarten. You can do that. Let's go. 5, 10, 15. So 5 plus 5 plus 5 equals 15. Have you noticed that multiplication is basically skip counting? You should have by now, so that's why I take the time in every lesson to do some skip counting, because if you can skip count, you can multiply. Now, let's take that repeated addition sentence and let's use that to write a multiplication sentence, okay? So all I have to do is look at what I have. Now, one of the things I always tell my students is don't make up things. Do not write something that you don't see, okay? So when you're writing those numbers down, they should mean something. What I mean is, you should, if I write a number down, I should be able to see that number in this picture somewhere. If I don't see that number in this picture somewhere, that means one of my factors or my answer is wrong. So let's start with my first factor, okay? And when I'm talking about factors, I'm just talking about the numbers we multiply together to get our answer, okay? So my first factor, I always start with the number of groups. That's my first factor, okay? What is my number of groups? I have 3. So I see 3 in this picture because there are 3 groups, correct? All right, number of groups times size of the group, okay? What's the size of the group? What did I tell you the size of the group was? That's correct. It is literally how many are in each group, all right? So how many are in each one of these 3 groups? 5. Once again, I should not be writing down any numbers that I don't see in my picture. I see 3 in my picture because that's the number of groups. I see 5 in my pictures because I see 5 red circles in each one. Now, we want to know our total. Remember, I told you you can skip count. So, let's skip count by 5 to find our total. 5, 10, 15. So 3 times 5 is 15. Boys and girls, where do I see 15? I should see 15 somewhere in this picture. Where do I see it? That's correct. That is the total number of red circles in all three groups, okay? So when we're writing up, when we're using our pictures, we should be able to see each number in that picture somehow, all right? If that makes it any easier to see. All right, let's jump into our application problem. Once again, with our application problem, we always want to use RDW. What does RDW stand for? That's correct. Read, draw, write. You can never go wrong with that formula, okay? Let's go. Jordan uses three lemons to make one pitcher of lemonade. He makes four pitchers. How many lemons does he use all together? Use the RDW process to show your solution. Now, you guys, when I'm looking at this, one of the things that I wanted to point out was that he uses three lemons to make one picture. So what I like to do is to visualize the problem. So when we're thinking about a picture, what is a picture? Have you ever seen your grandmother or your mom make tea or Kool-Aid? Those things that they use to pour in it, that's a picture, you guys. So he made some lemonade, and one of those things that we use to pour our lemonade or our Kool-Aid or our tea or whatever that we make. So we want to visualize what he's doing. So he uses three lemons to make four pictures, all right? So how many pictures does he make? He makes four of them. So we're literally saying that he uses three lemons in all four pictures. Not that he uses three in total, that he uses three for all four, all right? So my question asks me, how many lemons does he use all together, all right? So you can also do a tape diagram for this one, guys. Let's start here, guys. Let's draw a piece of tape. Now, let's think about what we have here. I need to know how many groups I have. Well, how many pictures of lemonade did he have? He had four. Now, to make four groups, I always want to make one less line. So for four groups, I'm going to make three lines, okay? One, two, three. So these four groups represent my four pictures. Now, the size of each group will tell me how many lemons he used in each of the pictures. How many lemons did he use? He used three. So in each of these pictures, he used three. Now we can solve this two ways. We can solve it with repeated addition, or we can use multiplication. Let's do both. All we have to do is take the threes and add them together. 3 plus 3 plus 3 plus 3 equals 3 plus 3 equals 6. 3 plus 3 equals 6, and 6 plus 6 equals 12. Now, we can also use this tape diagram to make a multiplication sentence. Remember what I told you the formula was. It's the number of groups times the size of groups. We have four groups, 1, 2, 3, 4, times the size of each group, 3, equals 12. So let's go back to our question. How many lemons does he use altogether? Remember, I always tell my students, if they ask you a question, you need to answer it. So he, or we can say Jordan, uses 12 lemons all together. So that was easy enough learning that based on what we did yesterday. All right, remember what our objective was today, boys and girls. Our objective was to relate arrays to multiplication, okay? So let's look at this array here. You should have learned arrays when you were in second grade, towards the end of second grade, okay? So let's go over what an array is. An array is an arrangement of objects in equal rows and columns, okay? So when we look here, what is this called when we're going horizontally? This is called a row. What about vertically? Those are called columns. So arrays are basically just rows and columns, okay? So this is how we count the rows. When I'm counting the rows, I don't say there's 1, 2, 3, 4 rows. I count my rows going like this. So 1 row, 2 rows, 3 rows, okay? So there are 3 rows. How many columns are there? 1, 2, 3, 4. So right here we have an array of 3 rows and 4 columns, okay? So if I'm looking at this row, I can rename this row when we're talking about multiplication. This row is also a group, okay? So how many groups do I have in this array? When I'm talking about groups, I'm still talking about rows. They're the same thing. So I have 3 groups. We can also say the size of each group is 4. Why do you think I'm saying the size of the group is 4? Because there are 4 rectangles in each group or row, okay? Now, we know that there are 3 rows of 4, which means we have 3 groups and the size of the group is 4, okay? To write this as an equation, we must first write the number of groups. What did I tell you in an array? A group is equal to the what? It's equal to the rows. So how many groups do we have here? We have 3. Very good. So our first number is 3. Remember I told you, it's the number of groups times, what did I already tell you yesterday? Size of the group. So we write the size of the group. Remember, the size of the group just means how many rectangles there are in each group. So how many rectangles do you see here? Let's fill in the blank. We have 3 groups, and how many rectangles are in each group? 4. So 3 times 4 equals what? How can we use this array to find the total number of rectangles? What can we do to find the total? That's correct. All we have to do is count. So let's count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 times 4 equals 12. The number of groups times the size of the group equals the total. Okay, boys and girls? Now, another way we can find the total is to skip count, boys and girls. So the first way I did it, I just counted all the rectangles. But I can also skip count by the size of the group. What is the size of the group here? It's 4. So you guys, let's count by 4s. Now, I know you probably never counted by 4s, but remember how I told you when we counted by 3, I said if you're counting by 3 and you're counting up, all you're doing is adding 3 every time. So how do you think you should count by 4s? You would add 4 every time you count it. So when I'm counting 4s, I want to just add 4 every time, okay? And you'll see what I mean by that when I do it. 4, 8, 12. 4 plus 4 is 8. 8 plus 4 is 12. So the first 3 numbers of our 4s are 4, 8, 12, you guys. Now, the final thing that I want to do is show you how I can use this picture and make it an array. Remember, an array is just a set of rows and columns, okay? So all we're going to do is translate this picture into an array. So let's look at what we have here, guys. How many groups do you see? You see 3 groups. And how many are in each group? That's correct. There are 5 triangles in each group. So we're going to redraw this as an array with 3 rows of 5 or 3 groups of 5. So let's do that. That's 1 row or 1 group. 2 groups, and how many groups do we need altogether? We need 3. Because we have 3 circles, and there are 5 triangles in each circle, okay? Now I can use this array that's not drawn perfectly to find a multiplication sentence to find the total number of triangles. Now remember what I told you the formula is. The formula is the number of groups times the size of the group. And remember how I told you, we don't count the groups like this. We don't say 1, 2, 3, 4, 5. We count the whole thing. We say 1, 2, 3. So the number of groups is 3 times the size of the group. What did I tell you the size of the group was? It's how many are in each group. So there are 5 triangles in each row. So it's 3 times 5 equals what? Let's just count by 5s to get it, okay? 5, 10, 15. 3 times 5 is 15. So there are 15 total triangles. Now remember, I told you, do not write numbers down that you don't see. You shouldn't be making up things, okay? All these numbers you should see in either one of your pictures. You should be able to see this 3 in either one of these pictures. You should be able to see the 5 and the 15. The 3 is the number of groups. We have 3 circles. The 5 is the triangles in each group. And 15 tells us there are 15 total triangles, okay? So make sure that all your numbers are accounted for. That's the end of my lesson 2. I'll see you next time for lesson 3. Bye-bye.